Hello class, welcome to the fourth lecture on programming in C. So in this lecture we'll be talking about software components. We'll start with some rudimentary understanding of what a software is, a little bit of classification, and then what we'll do is we'll move on to the software components used in converting the programs we write. Okay, we'll see that in a little bit detail. So first of all, software, right? So what is software? Any software is a set of instructions and data used for some specific purpose. So what do you mean by when you say some specific purpose? The thing is that that specific purpose should be done using the computer hardware, right? Some specific purpose done or executed by using the hardware. So that is software. So essentially you can say that you are the user here and you have let's say you have the hardware here, right? The like we mentioned in the previous lectures, you have the microprocessor, you have the memory, you have the motherboard, things like that, you have the monitor, keyboard. So all these are hardware things. For you to use that, you need some sort of medium in between so that the hardware understands what you're saying and it will do that specific purpose for you. So that is that thing, that gap is being filled by software. So software, like, it is not like there is one software for all your requirements, or there is like a one solution. No, it's not like that. Like, we use different softwares for different purposes, and based on the type of purpose, software can broadly be classified as two. Okay, can be broadly be classified into two, and that is system software and application software. So what is the difference? So like from the name itself you might be getting a little bit of understanding. So basically system softwares are softwares which directly handle the hardware. Okay, it directly handles the hardware. So you can say that it is used to manage and control hardware of a computer system. Like, it is used to manage and control the hardware system. An example which you will understand right away is the operating system. Right, operating system. Whether you are using Windows or Ubuntu or whatever, your operating system is an excellent example of a system software. That is what your operating system, purpose of your operating system is that it is a platform for you to use the hardware, right? It serves as a platform. So what all does this system software do? Some specific let's say uses or purpose of a system software are process management, then memory management, secondary storage, let's add that to it, memory and secondary storage management. Okay, then you have input output device management. Right, you have file management. Right, some of these terms you will be identifying right away. This memory, secondary storage, all we discussed in the last lecture, and I/O also we slightly discussed. So that is these hardwares has to manage, and when it comes to process, whatever it is like, whatever software is running in the computer, some basic software, some basic things will be running. That is required in the computer, like that is called as a process, let's say, in a basic understanding. So multiple processes will be running in the system, and you need to manage them so that they won't clash, right? So that is basically process management. Then there is file management. What do you mean by files? Files are like whatever things, for example, you are creating a text, you are using Word software or Microsoft Office, and you're writing something in it and you're saving it. You are basically storing it as a file. So the thing is that these files have to be managed. For instance, the processor, the operating system, the system software has to make sure that the same file is not being written or edited simultaneously by different processors or system softwares. So things like that. So basically, resource management is the key function of a operating system, or system software. Operating system being the main example that you can say regarding system software. Right. So when it comes to application software, so how does it work? It doesn't directly it doesn't directly interact with the hardware. If at all if at all an application software requires some interaction with the hardware, it is done through the system software, and usually some sort of process will be made available for the system software. So the function of what application software, how you can say this classification is that it is used for performing specific tasks for the end user. Right. For performing specific tasks for the end user. The other thing you have to remember is it works on top of system software. Right. It works on top of system software. Right. So one abstraction or figure we can use to understand how this whole scenario works is, suppose we have the hardware, right? It is the resource, and okay, let me just draw a new figure here. Suppose we have the hardware here, okay, and to use the hardware, what do? We use the system software. So right, so whatever interaction has to be taken place, it is done through the system software only, right? And system software as such is of no use, right? That is the purpose of system software is just to manage the different hardware components. You need application software to actually use the system software and thereby use the hardware, and the user will be using this. For example, If you just have the Windows operating system, there is no purpose, right? If you want to browse the internet, you have to use some sort of browser, like a Firefox or any Google Chrome or Internet Explorer or something. If you want to write something, if you want to make a note, you need a Notepad++ or something like that. Likewise, if you want to play some media content, you need a VLC player, Windows Media Player, whatever. So for you to use the system software, you require application software, right? And application software runs, it is a layer that is running on the system software, which in turn manages the hardware. So this is a brief example, brief description regarding system types of software, system software and application software. Like here, for example, you can write whatever, a browser, media player, even your in your mobile phone, different apps are there, right? All those are system software. Any app that you're using in your mobile phone is a application software running on the system software. Okay, so that is regarding the basic software of a computer system. Now what we'll do is we'll move on to what a programming language is, and the different types of programming languages, and how we use them in a very, let's say, bird's eye view manner of the thing. Okay, now let's move on to programming languages, right? That is our main topic. So programming language. Right. So in the programming language, in the previous lectures we had mentioned that we have the processor or CPU, right? And it takes some input, it gives some output based on a set of instructions, right? So a programming language deals with this part, how to write instructions. Okay, how to write instructions. The thing is that basically how are these instructions stored in memory? So in earlier classes I had gave different types of memory and all. So what is memory? Memory, a single unit of memory, right? A single unit of memory. Suppose I have a memory unit and it is of length 4. Okay, I'm saying 4 bits. It means that it is a collection of 4 unit, let's say 4 cells, which can either store a 1 or a 0, a 1 or a 0, a 1 or a 0, 1 or a 0, right? So with this ones and zeros, what we can use, we can have 16 patterns. We can have 16 pattern means we can store 16 different types of things here. It can be anything, right? And what if we expand that to 8 bits, right? If you expand that to 8 bits, you can have not 16, you can have how many? 32. No, not 32. It is actually 2 to the power of 7, right? You have 2 to the power of 7, or you can have 2 to the power of 8. Sorry, my mistake. You can have 2 to the power of 8 combinations. That is a large number. that is 256 combinations, right? That is, if you have a device capable of storing ones and zeros, 8 ones and zeros side by side. For example, you can have 1000 1000. This is one of the 256 patterns possible. Or you can have 00000001, right? Or 11111111. So you can have different patterns. So a pattern is one thing. How you assign meaning to it, right? How you assign a certain meaning to it, that is what gives a purpose to the pattern. So this the way we use instructions is that any instruction you write will be some sort of a pattern, will be a pattern of ones and zeros. It will be stored in a memory, right? So suppose this is your memory, so like it continues, and each of these blocks, right, each of this is a single 8-bit of memory, right? Each of this is 8-bit, okay, 8-bit memory, and you have so many such memory locations. And this can be suppose instruction 1, this can be suppose instruction 2, likewise. Maybe some of it might be some sort of data. So this is, and this instruction is taken to the CPU and that is executed. That is how basically it works, right? We store the data on instruction as bit patterns in memory locations, and there will be so many memory locations stored, and each of these instruction is taken to the CPU and it is executed, right? That is the basic idea. So why am I talking about this when I am talking about programming languages? What was I saying about programming language? Programming language is about how we implement this or how we represent this instruction. Basically, in any computer system, instruction can be understood by the CPU only in this format, right? We are going to study C programming. No matter you are studying C programming or Java or Python or whatever, ultimately the processor will only understand this one, this ones and zeros, right? So depending on how you represent your instruction, how you represent your instruction, we classify our programming languages. So what is that classification? We have the basic the most rudimentary type of language, which is a machine language. That is, we will be writing directly in the language that the processor understands. That is ones and zeros, right? And whichever other language you are using, ultimately that program has to be converted. The instructions you are writing in the program has to be converted into something like this. That something like this is the machine language. Earlier in the evolution of computers, in the beginning, computer programmers, even for implementing the most basic simple task, they had to write programs in the machine language like this. Okay. Then there is what we call as an assembly language. Assembly language. Okay. Assembly language is also, it is something closer to the machine language. Actually, we are writing instructions that the CPU can directly execute, but the thing is that we won't be writing it as ones and zeros, right? For example, if 10101111 is the bit pattern required for implementing an addition, right? This will be the machine language. But we won't, in assembly language, what will we be writing? We will be writing something like add a comma b. So this is actually an instruction that a CPU can directly implement, but this is for the programmer to understand easily, right? Dealing with bit patterns is a little bit difficult for anyone. So what people did is they came up with assembly language. So that is a more readable form of language, but again it is directly translatable to this machine language. Then we have what is known as the high level languages. High level languages. What do you mean by that? These are languages like C, Java, whatever you are learning as a programming language. So in that we won't be directly using programs or instructions that can be understood and executed by the CPU. Each line or each sentence in a higher level language, programming language, it may or may not be, usually it will be a combination of multiple of these basic instructions, rudimentary instructions, right? And it has to be converted to machine language. Even assembly language has to be converted to machine language for understanding, for the processor to understand, right? So machine language means ones and zeros, right? And it has what instructions understandable by processor. In this, it is a human readable form of machine language, let's say. But when it comes to higher level language, it is more complicated, and what each sentence is what composed of different let's say machine language instructions. Okay, so anyway, we don't have to go in detail to what machine language is, how assembly language is done and stuff like that. So we'll be basically dealing with high level language, right? So so as a user, most of the times we'll be dealing with high level language, or as a user we'll be dealing with assembly language. And either way we have to convert it to machine language, right? So that is, we need some sort of a translator, because this is the language that the processor understands and this is the language that we know. So basically we need some sort of translator. So that translator, which does the purpose of translating assembly language to machine language, is called as an assembler. And the translator that translates higher level language to machine language is actually two types are there. It can be a compiler or it can be an interpreter. Right. So for us to convert higher level language to machine language, you use a compiler or an interpreter, and for us to convert assembly language into machine language, you use an assembler. Okay. So what is the main difference between compiler and interpreter? Because like assembler, it is straightforward, assembly language to machine language. So here we have two things, two translators to serve the same purpose, a compiler and interpreter. So what is the difference? Is that compiler it takes the entire program, converts or translates the entire program, and it executes only if the program is completely okay. Completely error free, right? Like what errors and all we will talk about later. Error free. Error free means if that is there should not be any mistake from as far as the program point of view, relating to the language that you are using, and some sort of basic logical mistakes also you will find, right? Interpreter what is it? So it is the opposite of this compiler. It translates or it converts or translates and executes line by line. Okay, it translates and executes line by line. So the thing is that it has to deal with errors as and when they come. And when they occur, that is the main difference. There are some more difference, but the main thing is this one, that is it converts the entire program as a whole, compiler, and interpreter it translates and executes, right, line by line. So that is the thing that is of main consequence to us as far as the scope of this course is concerned. And you can look up in the internet for if you want to know more about compilers and interpreters and the differences. So that is regarding this software part, what it is and all. So I'll be closing my lecture now, and in the next class onwards we'll start with algorithms and flowcharts. That is, we are not exactly entering into programming, C programming, but the thing is that we'll be starting the concept of structured problem solving. We'll learn how to solve problems. Then once we have a grasp over how we can solve problems, we will move on to the language, C language, and we'll be spending quite a lot of time regarding algorithms and flowchart. We'll be solving a lot of problems in that part. Okay, so thank you.